Hello everybody, welcome back to Mr. Morrow's Algebra class. Today we are going to be talking about 1-4 part 2. Remember, 1-4 is one complete section on equations, but it takes into consideration that you've already learned and mastered single step, two-step, multi-step, and literal equations, and it kind of just gives you a review for it. So this is part 2 from my notes, but 1-4 is just one section. Anyways, today we're going to be talking about solving multi-step and literal equations. Now, when we're solving multi-step equations, surprise, surprise, the goal is still to isolate the variable, get the variable all by itself. That is always the goal for any equation. Again, I hate to be repetitive, but you're solving for x over 1. You're solving for x in the numerator, and that's very important. Now, let's go over the procedures for solving multi-step equations. Number 1, complete any distributive property first. What I mean by that is, let's say I have an equation that looks like this. 3 times x plus 2 equals, let's say, 4x minus 5. Okay? So complete any distributive property first. Well, in this example that I'm giving you here, this is the distributive property right there. So we're going to complete it. Multiply 3 times x plus 3 times 2. So you're going to have 3x plus 6 equals 4x minus 5. Step 2. Combine like terms on both sides of the equations. So if I have like terms on either side, I combine them. Here, 3x and 6 are not like terms, so I cannot combine them. Here, 4x and negative 5 are not like terms, so I cannot combine them. But if I did have terms to combine, for example, if I had over here 3x plus 6 plus 2 equals 4x minus 5 plus x, sorry about that. Let's go ahead and just move this over. Okay. Negative 5 plus x, well then in that case, you'd have 3x plus 8, because you combine those like terms, and that's going to equal 5x minus 5, because you combine that x and those 4x's. So, go ahead please, and remember to combine like terms on both sides of the equation. Now, step 3. Move all the variables to one side. So let's go back to our original little example here. I got a 3x on the left side and I have a 3x on the right side. I need to move those variables to one side. I really don't care which side they go to. I don't care if it's going to end up positive or negative. I really don't care. That is a personal choice. Me, I'm going to go ahead and make it positive. So I'm going to subtract 3x to both sides. Now, why? Why did I subtract? Why didn't I divide it? Sometimes people divide it. Well, I have a 3x plus a 6 here, okay? To get rid of this positive 3x, to move that sucker over, I need to cancel out a positive 3x. How do I cancel out positive 3x? By subtracting 3x. So 3x minus 3x, that cancels, and I got 6 equals x minus 5. Now you're left with a single-step equation, okay? Sometimes it'll be a two-step, sometimes it'll be a single-step. So I have a single step here, so all I have to do is add 5 to both sides. X equals 11. That's step 4, undo addition and subtraction. And then last but not least, if I had a coefficient in front of x, I would undo multiplication and or division. So let's go ahead and just do some practice, because practice makes perfect, especially in mathematics. Let's practice solving some multi-step equations. All right, let's see what we got here. I've got negative 20 equals negative 4x minus 6. Actually, let's see. Actually, if I can zoom this a little bit. No, I don't think I can. Okay, I don't think I can zoom this. I do apologize about that, but hopefully you guys can see it. What I'll do is I'll write it out here. So I got negative 20 equals negative 4x minus 6x. Well, first step, undo any distributive property. I don't have any distributive property, so next step, combine like terms on both sides. Well, this is going to be negative 20 equals negative 4x minus 6x. When the signs are the same, you add and keep the sign. Negative 10x. Divide by negative 10, because now I'm left with a single step equation. And I got x equals 2. So x equals 2. Next. Go ahead, I'm going to just erase it. Okay. Okay, next. I got 6 equals 1 minus 2 plus 5. So I've got 6 equals 1 minus 2n plus 5. There's no distributive property. Next, like terms on both sides. Well, I got a 6 here, and then 1 plus 5, those are like terms, so that's 6 minus 2n. Now we're left with a two-step equation. I'm going to undo addition and subtraction first. So I'm going to subtract 6 to both sides. 0 equals negative 2n. Now I got to get the n alone. The relationship between negative 2 and n is multiplication. I cancel multiplication with division. Divide by negative 2 to both sides. N, that cancels to 1, equals 0. So n equals 0 for number 2. Okay, number 3. Oh, sorry about that. I'm going to have to actually delete these out, erase these out. Okay, next. Number 3. I got 8x minus 2 equals negative 9 plus 7x. So I've got 8x minus 2 equals negative 9 plus 7x. Okay, distributive property, there's none. Add like terms on both sides. I don't have like terms to add. Bring the variables all to one side. Yes, I've got an 8x on the left and a 7x on the right. So I'm going to subtract 7x's from the right, and I'm going to subtract 7x's to the left, because whatever I do to one side of the equation, remember, I must do to the other side to keep a balance, equality. So I'm going to have x minus 2 equals negative 9. Now I have a one-step equation. The relationship between the x and the 2 is subtraction. Okay, I got to get rid of that negative 2. So I add 2 to both sides. And x equals negative 7. All right. Next, I've got a plus 5 equals negative 5a plus 5. Distributive property, none. Combine like terms on both sides. There are no like terms to combine. Get the a's all together on one side. Okay, that we can do. So I got a plus 5 equals negative 5a plus 5. I'm going to keep the a's positive, so I'm going to get rid of this negative 5a by adding 5a to both sides. Remember, whatever you do to one side, you must do to the other side. A plus 5a's is 6a's plus 5 equals 5. Now I'm left with a two-step equation. Subtract 5 to both sides. 6a equals 0. Divide by 6 to both sides. A equals 0. Why did I divide by 6, you may be asking. Why did you do that, Mr. Moore? Well, because the relationship between 6 and A is multiplication, and I cancel multiplication with division. So for number 4, A equals 0. All right. Let us continue. Now we're going to get to some special cases, okay? You're going to see what happens here, and I really need you to understand this. So please, please pay attention. For number 5, I have 4m minus 4 equals 4m. Okay. A lot of times people get confused with this, so please pay attention. There's no distributive property, so we don't have to worry about that. No worries. Now we got to combine like terms on both sides. Well, these sides don't have any like terms to combine, so we don't really want to have to worry about that. But now let's get all of the variables together on one side. Well, there we can perform this operation. I have a 4m on the left and I have a 4m on the right. So I'm going to subtract 4m to both sides. And I'm going to be left with negative 4 equals 0. Now, this is where the confusion comes. My students are always thinking, okay, The answer is negative 4. No, that's wrong. This is saying that negative 4 equals 0. The m is gone. The variable has gone bye-bye. So you got to ask yourself, is negative 4 equals 0? Is that true or false? Well, in this particular case, it is false. And it is false because there is no solution. No value of m is ever going to make this equation true. So, when you cancel out the variables when we are solving equations, and you get a false statement at the end, it can only be a false statement if you have eliminated the variables. Remember that. And you get a situation like this where it's negative 4 equals 0. That is false, and that is a no solution. Okay, no solution. However, sometimes you'll get what's called all real solutions. Let me explain that right now. Let's say I had 4m minus 4 equals 4m minus 4. Well, most of you can see that both sides equal each other, okay? It's called an identity, and this is called all real solutions. But not just because they look like each other, they're not always going to be so simple. We're going to follow the procedures, though, and I'm going to show you why it's all real solutions. There are no distributive properties to complete, and we don't have any like terms on both sides to combine. But I do have to move the variables to one side. So I'm going to subtract 4m to both sides. And what's going to happen here is I got negative 4 equals negative 4. Now again, is that true or false? If it is true, which it is true because all real solutions. Okay? That means that any value of m can be plugged in and the equation will hold true. For example, let's say that m was 3. Well, 4 times 3 minus 4 equals 4 times 3 minus 4. That's 12 minus 4 is 8, which does equal 8. All real solutions. So if you have a false statement once you have eliminated the variables, there's no solution. If you have a true statement after you have eliminated the variables, it is all real solutions. Okay. Sorry about that little pause there. Let's continue. Okay. Let's check out number 7. We have no distributive property. We cannot combine any terms on either side, but we can move the variables to one side. So I'm going to keep the variables positive. All right, so negative 5p to both sides, and actually that may be hard for you to see the original problem. I apologize. 5p minus 14 equals 8p plus 4. So I'm going to subtract 5p to both sides. Cancels. I got negative 14 equals 3p plus 4. Now I have a two-step equation. I'm going to undo addition and subtraction first, so I'm going to subtract 4 to get rid of the positive 4 that is being added to the 3p. It's going to give me negative 18 equals 3p. The relationship between 3 and p is multiplication. I cancel out multiplication with division. P equals negative 6. Okay, here I've got p minus 4 equals negative 9 plus p. Well, I don't have any distributive property. I cannot combine like terms on either side, but I can get all of the variables on one side. So I'm going to subtract p to both sides, and I'm going to get negative 4 equals negative 9. That is a false statement, so that is no solution. Okay. Now let's complicate a few things, and let's add some distributive property to the mix. All right. Now I've got for number 9, negative 8 equals negative times x plus 4. Let me explain something real quick, a little side note. This negative here, that's really represents a negative 1 being multiplied to this x plus 4. So you're going to really distribute a negative 1 to that x plus 4. Okay? So, first step in multi-step equations, complete all distributive properties first. So I've got negative 8 equals, distribute the negative x minus 4. Now I have a two-step equation. I'm going to undo addition and subtraction first. I'm trying to isolate the x, so I got to get rid of the negative 4. So I add 4 to both sides. Negative 4 then equals x. Let's look at number 10 now, please. Let's check out number 10. We've got 12 equals negative 4 times negative 6x minus 3. Undo, or rather, I'm sorry, complete distributive property first. So I've got 12 equals negative 4 times negative 6x is 24x. Then negative 4 times negative 3 is plus 12. Now I have a two-step equation. I'm going to undo addition and subtraction. Since I want to get the x alone, I got to get rid of the 12 that is being added to the 24x. So I'm going to subtract 12 to both sides. That's 0 equals 24x. Be careful, that is not a no solution. Remember, in order for it to be a no solution or an identity with all real solutions, you have to cancel the x. So in this case, the relationship between 24 and x is multiplication. I cancel multiplication with division. Divide by 24. X equals 0. Hope that makes sense. I know you must be thinking, Mr. Morrow's crazy. He's giving us way too much work today. Yeah, I'm sorry. I got to make sure that you guys understand this, okay? So bear with me. 14 equals negative, parentheses, p minus 8. Remember, this negative on the outside here, that's a negative 1 being multiplied, distributed to the p minus 8. So when I distribute that negative, I'm going to get 14 equals negative p minus 8. Undo addition and subtraction, so I add 8 to both sides. 22 equals negative p. The relationship between the negative 1 and the p is multiplication, because remember, this negative p really represents a negative 1 times the variable p. So I'm going to divide by negative 1 to both sides, and p would equal negative 22. All right, how about 12? Negative, parentheses, 7 minus 4x equals 9. Distribute the negative. Negative 7 plus 4x equals 9. I got a two-step equation here now, so I'm going to have to get rid of the addition or subtraction first. This negative 7 is being added to the 4x, so I got to get rid of this negative 7. So I add 7 to both sides. 4x equals 16. Divided by 4, x equals 4. All right. Let's complicate things a little bit more now. All right. Number 13. I've got negative 18 minus 6k equals 6 times 1 plus 3k. Okay, first step, complete any distributive property. So I got negative 18 minus 6k equals, distribute the 6, that's 6 plus 18k. Combine like terms on both sides. I don't have any like terms to combine on both sides. I get all of the variables on one side. It's the next step. So I add 6k to both sides. Negative 18 equals 6 plus 24k. Now I have a two-step equation. I got to get rid of the 6 because it's being added to the 24k. I undo addition and subtraction first. I subtract 6 to both sides. Negative 24 equals 24k. The relationship between 24 and k is multiplication. I undo multiplication with division. divide 24 to both sides, and negative 1 equals k. Okay, sorry about that. Let's go ahead and erase this. Next, I've got now 5n plus 34 equals negative 2 times 1 minus 7n. First step, complete all distributive property. Okay, I got 5n plus 34 equals, distribute that negative 2, so I got negative 2 plus 14n. Now, let's go ahead and combine like terms on both sides. I don't have any like terms to combine. So now let's get the variables together on one side. So I'm going to subtract 5n to both sides. I'm going to be left with 34 equals negative 2 plus 9n. Now I've got a two-step equation. I'm going to undo addition and subtraction first. So I'm going to add 2 to get rid of the negative 2. I got 36 equals 9n. Now the relationship between 9 and n is multiplication. I'm going to divide to cancel out multiplication. Divide 9 to both sides. N equals 4. Done. Excuse me. All right. Let's do this. Continue. A little bit more complicated, and we're already getting to the end of this section. All right, let us continue. Number 15. I got 2 times parentheses 4x minus 3 minus 8 equals 4 plus 2x. First things first, complete all distributive property first. So I'm going to distribute that 2. So I get 8x minus 6 minus 8 equals 4 plus 2x. Now, combine like terms on both sides. We can do it here. This is going to be 8x. And the negative 6 minus 8, when the signs are the same, you add and keep the sign. So that's 8x minus 14 equals 4 plus 2x. Now let's get the x's together on one side. So I'm going to subtract 2x to both sides. I got 6x minus 14 equals 4. Now let's go ahead and solve this two-step equation. Add 14 to both sides. 6x equals 18. Divide by 6 to both sides. X equals 3. Hope that made sense. Let's do another one. All right, 16. I got 3n minus 5 equals negative 8 times 6 plus 5n. Let's go ahead and follow the same procedures. First, distributive property. All right, 3n minus 5 equals negative 48 minus 40n. Now let's go ahead and combine like terms on both sides. I don't have any. Let's go ahead and combine the variables on one side. Sorry about that. Let's go ahead and get the variables together on one side. So I'm going to go ahead and add 40n to get rid of the negative 40n to both sides. And that's going to be 43n minus 5 equals negative 48. Two-step equation now, so I'm going to undo addition and subtraction first. So I get rid of that negative 5 by adding 5. I got 43n equals negative 43. Divide by 43 to both sides. And n equals negative 1. I hope we're getting the rhythm of this. It's not that bad. It's pretty easy as long as you just follow the procedures every time. Follow the steps. All right. Next, I've got a negative times 1 plus 7x in parentheses minus 6 times negative 7 minus x in parentheses equals 36. Distributive property. That's the first step. So I'm going to distribute that negative 1 to both sides. So it's going to be negative 1. Sorry. Negative 1 minus 7x. Distribute that negative 6 to everything inside the parentheses. So that's plus 42 plus 6x equals 36. Combine like terms on both sides. Well, negative 1 and 42, that combines to become a 41. And negative 7x plus 6x, it's going to be minus x, equals 36. Now I'm left with a two-step equation. I've got to get the x alone. So I know that 41 is being added to it and a negative 1 is being multiplied to it. So I got to get rid of the positive 41 by subtracting 41 to both sides, because I undo addition and subtraction first. Negative x equals negative 5. The relationship between that negative and that x, that's a negative 1 being multiplied to the x. So I divide by a negative 1, and x equals 5. All right, 3 more. Number 18. I've got negative 3 times 4x plus 3 plus 4 times 6x plus 1 equals 43. First step, distributive property. So I'm going to distribute this negative 3 to everything inside parentheses and this 4 to everything in parentheses. So I'm going to be left with negative 12x minus 9 plus 24x plus 4 equals 43. Combine like terms on both sides. Negative 12x and 24x are like terms. Negative 12 plus 24 is 12x. Negative 9 and positive 5 are like terms. I'm sorry, negative 9 and positive 4 are like terms. Negative 9 plus 4 is negative 5, which equals 43. Now I have a two-step equation. I'm going to undo addition and subtraction first. So I add 5 to both sides. 12x equals 48. Divide by 12 to both sides to cancel out the multiplication of 12 times x. 12's cancel. X equals 4. All right. 2 more. All right, 2 more. I've got 24a minus 22 equals negative 4 times parentheses 1 minus 6a. So first step, complete all distributive property. So 24a minus 22 equals, you're going to distribute the negative 4 to everything inside the parentheses, so that's negative 4 plus 24a. Combine like terms on both sides, which I don't have. Get the variables together on one side. I can do that, so I'm going to subtract 24a to both sides. The a's cancel, so remember, either this is going to be a true statement in which it's an identity and it's all real solutions, or it's going to be a false statement, which in that case it is no solution. Negative 22 equals negative 4, that is false. So that is a no solution. Done. Last but not least, this one's good because it's got everything combined. I've got negative 5 times parentheses 1 minus 5x plus 5 times negative 8x minus 2 equals negative 4x minus 8x. All right, first step, complete all distributive property. So I'm going to distribute this negative 5, and I'm going to distribute this positive 5. So I'm going to get negative 5 plus 25x minus 40x minus 10 equals negative 4x minus 8x. Combine like terms on both sides. Negative 5 and negative 10 are like terms, so that's negative 15. 25x and negative 40x are like terms, so that's going to be negative 15x. Equals negative 4x and negative 8x are like terms. Negative 4x minus 8x is negative 12x. When the signs are the same, you add and keep the sign. Now, I got to get the variables together on one side. I'm going to add 15x to both sides. Now I'm left with negative 15 equals 3x. I'm going to undo multiplication with division because the relationship between the 3 and the x is multiplication. So I'm going to do it by dividing 3 to both sides, and x will equal negative 5. I hope that makes sense. I'm going to erase this in a second. I'm going to scroll down to the next page, and it's going to give you all the answers in red. And then that way, just in case you miss something, you get to see it again. All right, here we go. Okay. All right. Now, we're done with multi-step examples. Now, let's practice solving literal equations. And I am sorry I misspelled that. Let me fix that real quick. Okay. Now we're going to be solving literal equations. Literal equations is no different than solving multi-step or regular equations. The reason that they're called literal equations is because you're going to now be solving for a particular variable from a given set formula. All right? I'm going to give you a formula, and you're going to solve for one of the variables of that formula. The procedures are exactly the same. For all of these here, the letter, or the variable rather, in parentheses, is the variable that we are solving for. All right, so let's do this. Number 1, P equals IRT. I want to solve for T. Same goal as before. I want to isolate the variable, get that variable all by itself. The variable I want to get all by itself in this case is the T. What is the relationship between the I, the R, and the T? They're being multiplied. How do you cancel multiplication? With division. So I'm going to divide by IR to both sides. Cancel, cancel. T equals P over IR. Done. Here, in number 2, A equals 2 times length plus width. I want to solve for W. All right, well, you could do this one of two ways. You could distribute and then subtract the 2 and then divide by 2. Or you can get rid of this 2 immediately by dividing by 2 to both sides. That's going to give you A over 2 equals L plus W. I want to get the W alone, so I subtract L to both sides. A over 2 minus L equals W. Next, number 3. This one's pretty easy. Y equals 5x minus 6, and I want to solve for x. Well, I want to get the x alone, so I add 6 to both sides. Y plus 6 equals 5x. I want to get the x alone, so I divide 5 to both sides. So x equals y plus 6 over 5. Number 4. Number 4 is 2x minus 3y equals 8, and I want to solve for y. So I got to get that y alone. So I want to get rid of this 2x. So I'm going to subtract 2x to both sides. Negative 3y equals negative 2x plus 8. Remember, you can't combine that x and that 8 because they're not like terms. Now I want to solve for y, so I want to get the y alone. So the relationship between negative 3 and y is multiplication. I cancel out multiplication with division, so I divide by negative 3 to both sides. And y is going to equal negative 2x plus 8 divided by negative 3. Okay, next. 5 plus x divided by 3 equals 5. I want to solve for x. Well, this 3 is in the denominator here, okay? Let me write this over here so you can see it a little bit better. Equals 5. Remember how we get rid of the denominator? You just multiply by its reciprocal, right? Same thing as getting rid of a fraction. So this is 1 over 3, so I'm going to multiply by 3 over 1. So I've got x plus y now equals 15. I want to solve for x, so I subtract y to both sides. X equals 15 minus y. That's for number 5. All right. Let me go ahead and move this up. So number 4, I forgot I skipped number 4. Oh, actually, no, I didn't. Sorry about that. I did do that. Okay, number 6. Y equals mx plus b, and I want to solve for b. So, easy. I want to get the b alone, so simply subtract mx to both sides. Y minus mx equals b. Done. For number 7, ax plus by equals c, I want to solve for y. Cool. Subtract ax to both sides. So I've got by equals negative ax plus c. I want to solve for y, so I divide by b. And y equals negative ax plus c over b. Okay. Hope that's making sense. Let me rewrite this one a little bit better. Number 8 is a equals 1/2 times h times b plus c. Okay, I want to solve for the b. So the first thing I'm going to do is I'm going to multiply everything by 2 over h. Why? Because if you really combine this 1 and this h, I have a equals h over 2 times b plus c. So go ahead and multiply by the reciprocal of 2 over h. So I'm going to have 2a over h equals now, because this guy, this guy, this guy, this guy cancel, b plus c. Subtract c to both sides, and you're going to have 2a over h minus c equals b. Okay? And in a nutshell, that's how you solve for literal equations. You just use the same procedures, but this time they're all going to be in variables. Now, throwing up a few extra ones here. Unfortunately, I'm not going to have time to complete these. I want you just to write these down and try to solve these on your own. Okay, we did up to 8. This is up to 16. And these are the last two up to 20. Now, there's one type of problem that was not given here, and I gotta show you how to do it. So go over these, okay, do these on your notes, and then we'll go over them in class. But one type of problem that I want to show you. Let's say they give you something like a equals, let's see, 5 plus b over c. And they want you to solve for c. Well, in this case, a lot of people get confused. Please remember that when we want to solve for c, we want to solve for c over 1, not 1 over c. This c is in the denominator. So when you see it in the denominator, you got to move it to the numerator. How do you do that? Multiply by the reciprocal. So you're going to multiply this whole sucker by c over 1, because remember, this is 1 over c. So the c's cancel, multiply c over 1 to both sides. So this is ac equals 5 plus b. Now, the a is being multiplied to the c. I want to get the c alone, so I get rid of multiplication with division. Divide a to both sides. C equals 5 plus b over a. And the last one, I promise, is one like this. What did I tell you? A equals BC plus BD plus BE, and I want you to solve for B. Well, I don't know if you guys remember, but in pre-algebra and algebra 1, you did do something called factor. And when you factor something, that means you're pulling the same variable out of every term. So in this case, a b is in all the terms. So let's factor out that b, okay? Remember when we factor out a b, it's kind of like we're dividing by b, and that's going to this, this, and that. So when I factor out a b, I'm going to have a equals b that I factored out. bc divided by b is c, plus bd divided by b is d, plus be divided by b is e. Now, how do I get the b alone? The b is being multiplied to c plus d plus e. So divide by c plus d plus e to both sides. c plus d plus e. Those cancel. A over c plus d plus e equals b. Thank you so very much. Have a wonderful day. Hope you learned a lot. Bye-bye.